Okay, this problem is chapter 8, section 4, and it's a word problem dealing with medicine dosages. And just quickly reading it, we have an antibiotic, amoxicillin, that's normally prescribed as a liquid suspension. And so what does that mean? It means that the amoxicillin part must be a powder of some sort, and they mix it with water, and then the powder antibiotic becomes suspended in the liquid. And the normal dosage is 90 milligrams of amoxicillin in 3 cubic centimeters of the liquid. And a physician says this person needs to take 240 milligrams per day. How much of the liquid would you take? Okay, so the physician has written the prescription in terms of milligrams of amoxicillin, and the normal way you prepare that is you put 90 milligrams of amoxicillin into 3 cc's of the liquid. So the question then is how much liquid? And so the unit of measure for the answer, whenever we get around to it, is going to be in cc's, cubic centimeters. But let's look at this on the pad just for a second together. And I've thought about this problem in a couple of different ways. One way is just to look at it and say, well, if it's 90 milligrams for 3 cc's, then how many milligrams is that for 1 cc? Well, just divide them both by 3, and you can get that it is in 1 cubic centimeter, there's 30 milligrams of the medicine, assuming that it's mixed uniformly. And then the question was, well, how much of this medicine do I need? Well, you need 240 milligrams of medicine. And how much in 1 cubic centimeter? 30. So you say 240 divided by 30, and you get 8 cubic centimeters. So the answer is 8 cc's. Now let's just put that in Math Excel and see if it liked it. And so we're going to have 8 cc's here. Okay, now let me just go back to the pad just for a second. So I got the answer right. Now there's 2 other ways that I thought about maybe doing that problem. I don't want to confuse you, but just to give you a little more work to think about. So if you set this up as a ratio and proportion problem, where you got milligrams is to cc's, milligrams is to cc's, and you use cross multiplying, you're going to have 90 times, 90 is to 3, 240 is to the unknown number of cc's. So you multiply 90 times this and get 90x, and 3 times this and you get 720, then divide by 90 and you get 8 cc's. Okay, so we get the same answer that way. The other method I did was, if I thought of it this way, I thought of it in kind of a dimensional analysis problem, I would say, well, my conversion factor here really is 30 to 1, 30 milligrams to 1 cc. Said differently, 1 cc to 30 milligrams. And then if I say, I'd like to use this conversion factor multiplication-wise in such a way that I can eliminate the units that I don't want, which would be, in this case, milligrams. I want to get back to cc's. So then I put the 240 up here with milligrams. The milligrams cancel, and this winds up being 1 times 240 divided by 30. And the unit that's left is cc's, and so I get 8 cc's. So there's about 2 or 3 different ways you can think about this problem, and I hope that one of those makes sense to you.